All right, guys, let's take a look at mean absolute deviation, not variation. It's actually really the same thing. It's another measure of variation we're going to talk about, just like our quartiles and our IQR and our outliers conversations that we had yesterday. We're going to look at a measure that specifically looks at the variation of each number. So I'm going to run through skip over the review real quick and take a look at this mean absolute deviation. That's really what it's called. So it's the average distance between each data value and the mean of the data set. So what that's really saying, if we're talking about an idea down here, we've got the mean. Let me switch to a different color real fast. If we have our mean here as our measure of center, we're taking different number points, X, Y, Z, A, B, and C. We're finding how far each one is from the mean on either side and saying how far, what's the average distance that it is from the mean. How far do they go? How far apart are they? Now, none of them might exactly be that distance, but what's the average distance? How far for all of these numbers, whether it's 5, 3, 1, 1, 2, 4, how far apart are they from the mean? And then we're finding the average distance of that. And when it says, so one of the keys that we talked about, the reason I have it here and really here is this idea of absolute. Really what we're talking about is absolute value. It doesn't matter if it's to the right or to the left of the mean. There will be no negative or positive, or no negative, because we're just talking about distance, how far it is from the mean. So that's why we have this idea of absolute. And we're going to bring back in our concept from earlier this year about absolute value. And that's where we're going to take a look at it. So let's get into how we do it. So mean absolute deviation, we're going to start with a smaller sample size of roller coasters here. So the first thing we are going to do, anytime you find mean absolute deviation, is since it is the mean distance of a certain number in the data set or of the numbers in the data set from the mean, the first thing we have to do is find the mean of the data set. So step one is to find the mean. Okay, so you're going to add everything up and say, okay, 58 plus 72 plus 88, 66. I'm going to go ahead and combine 40 and 60 to get 100 plus 128. That gives me 512. Divide that by 8. And the mean of this data set, we're going to say, is 64. Okay? So I've got a mean of my data set. That's the first thing I'm going to do. The second thing I'm going to do is find the distance each number is from that data set, from that mean. So I'm going to find the difference of the mean. So I missed a word, hold on. Find the difference between the mean and each data point. So it's going to be mean minus each data point. And because we have some that are above the mean and below the mean, we're going to use absolute value bars to show that we're not looking at the positive or negative value, where it is, which direction it from the mean it is. We're just looking how far it is. So what that means is I've got a significant amount of work here. I'm going to say 64 minus 58. And I'm going to say, okay, the number from that data set is 6. I'm going to say 64 minus 72. Okay, this time it would technically be negative, but because it's an absolute value, it's 8. 64 minus 88. Okay, and this time it's a little bit more, so it's, 24 from the mean. Okay, and then we have 64 minus 66. So now we're only 2 from the data set. Then we keep going. 64 minus 40, that's 24. And then 64 minus 80, that's 16. 64 minus 60, and that's going to show us a 4. And then finally 64 minus 48, and that shows us 16 from the data set. So the next thing I'm going to do, my last step to find MAD, and this is how we find MAD, our final step, and that's mean absolute deviation, is I'm going to find the mean of the averages. of the differences. Sorry, not averages, a mean of the differences. So I'm going to come in and go 6 plus 8 plus 24 plus 2 plus 24 plus 16 plus 16 plus 4. And I get a data set. Oh, I typed mine wrong. That's one of the biggest mistakes I typically make on a calculation like this. So let me retype my numbers. I get 100. So I add all these up, so I'm just going to double check my math real fast. 14, that's 15, 16. So this side, 16, plus that is 40. Let's check this side. That's 40, 20, so 100, so I've gotten it right. So I'm going to take the mean of that data set, and now I divide it by 8. And that tells me that the MAD, or the mean absolute deviation for this number, is 12.5 miles per hour. Okay? That's the mean of this data set. That's the mean absolute deviation of this data set. All right? All right, now it's your turn to give it a try. I want you to see the table shows the number of miles Katie jogged in 5 days. Find the mean absolute deviation of this data set. Okay? Be sure to round your final answers to the nearest hundredth if necessary, and describe the absolute deviation, what the absolute deviation represents. Tell us what it means at the end. Okay, go ahead and pause the video. It might take a few minutes to get this out, and then once everyone's done, you can hit play and figure it out. All right, now that you've had time to do it, the first thing you did is you figured out that the mean was 4 2/10. Okay? Now you're going to go through and just do the math. 4 2/10 minus 3. 4 2/10 minus 5. 4 2/10 minus 2. 4 2/10 minus 6. And finally, the last one is another 4 2/10 minus 5. So you get 1 2/10. You get 8/10. This time we're going to get 2 2/10. We're going to get 1 and 8/10. And finally another 8/10. Okay? So now that you've got all those data points, you're going to add them up. 1 2/10, 2 2/10, 1 8/10, and you're going to get a total. You got 6 8/10. You're going to divide that by 5. And that's how you're going to get your MAD of 1 36/100 miles. That's her mean absolute deviation. And really what that means is she ran an average of 4.2, but she could run, what it says is the absolute deviation, the typical run between that, while her mean is 4.2. Either way, she could have run 1 mile, 1 1/4 miles, 1 4/10 miles, either way. That's the average distance difference between each run. Okay? Now, it might not be 100% the same, but that's the average distance between the run. The distances between the runs. All right, now, so this next problem is set to figure out the top 5 and bottom 5 salaries of the 2010 New York Yankees. The salaries are in millions of dollars and rounded to the nearest hundredth. Find the mean absolute deviation of each data set. And really the key to this is to have a conversation about why we compare them. So I'm going to go ahead and just kind of jump in and talk about how to get the answers. And then we're going to discuss what we're having, okay? So the first thing you found was the mean at 23 4/10 for this side and at 41/100 for this side. Then you worked out the math and you figured out the mean absolute deviation. So you go ahead and do 23 4/10 minus 33 and kind of keep working all your way down. 23 4/10 minus 24 29/10. 23 4/10 minus 22 6/10, and you keep going all the way throughout until you get your final answer. And I'm just going to finish showing you my work so that you guys can see what we've got. Okay, all of these are inside their absolute value bars. So it's the work you figured out all the differences, 9 6/10. You figured out 0.89, 800, 2 77 hundredths, and 6 9/10. So you found the MAD for this one being $4 19 million. Over here, same idea. Sorry, this is 0.43. My apologies. 0.45. Sorry, 0.43 minus 0.45, 0.43 minus 0.44, 0.43 minus 0.43, 0.43 minus 0.41, and then 0.43 minus 0.41. So you get 200ths, 100th, 0, and 200ths. So the MAD for this side, we'll put it down here at the very bottom, is 0.01, and it's 0.014, so it rounds to 2.01. Okay, so you get a chance to take a look at how those work. So now what we really have to decide is, what can we explain on this? What does this data tell me? It tells me that the average distance between the salaries of our New York players is 4,190,000 from the top 5, and that the bottom 5 are pretty close together at just $10,000 difference. That's the average distance between them. And that really is what that tells me, is the salaries are way more variable at the top end. The bottom end, they're pretty low, that they're pretty consistent, that if you're making the bottom line, if you're the bottom 5 salaries, you're probably pretty similar. There's not a huge variation in those. Okay? Where if you're the top 5 salaries, there's a huge, big variation between each of those numbers. You can make a wildly divergent salary from the next player around you. So let's go ahead and have you practice one. So what I want you guys to do is, you can work with a partner next to you, or you can work with someone else if you have someone else with you, is I want you to figure out the mean absolute deviation of both sides. And then I want you to write me a sentence or two about what you've learned about that information. So go ahead and pause the video, and then when we're done, I'm just going to tell you what the MADs are for each one, and we'll focus mainly on what the few sentences would be to talk about what we learned. Okay. All right. So the first thing you found, you figured out everything here, is the mean absolute deviation of this side was 3. The mean absolute deviation of this side was 5 and 3300ths. Okay? The first mean you found, just to make sure you can test everything out, the mean for the first half was 55 and 5/10 degrees. The mean for data point 2, this is 10 a.m. For data point 2, the mean is going to be 75. Okay, so again, what that tells me is a lot of information. Okay, that it tells me the temperatures, excuse my poor handwriting, temperatures at 10 a.m. are more consistent. So that you know that that's pretty consistent data, that it's pretty common. There's not a lot of variation between the two. It tells me the temperatures at 2 p.m. have a greater variability. A greater variability means they change more often and have a wider range, because the larger the MAD, the more diverse the data, the more spread out your data is. Typically, what you're looking for, though, in data is, especially if you're trying to prove something is correct, you're looking for a pretty consistent set of data, and that your MAD would be pretty low. Okay? So you've got all this information. So for example, just to give you another example of what that might be, if I took the grades in my Honors Math 6 class, I would expect my mean absolute deviation to be relatively small. That everybody is our top level students. They're really good students. Everyone has a good gift towards math, and they work hard. They do their homework. That's not a question. Between their grades, there should be lesser variation than, say, maybe my Algebra 1 class, where I've got kids that are taking this class for the second time, or kids that are taking it for the first time and then really struggled in pre-algebra, or kids that are really close to honors level math students that maybe just didn't make the cut this year and are going to make it next year. So I would expect a much larger variation in my data. My mean absolute deviation would be much greater when it comes to their grades. I could have grades down in the 70s and grades all the way up into the high 90s, where in my honors classes, I kind of look between, most of my students are between 87, 88, and 94, 95. That's a pretty normal set of numbers. And that means the mean absolute deviation is going to be much smaller because the data is so much closer together. And that's kind of what I'm looking for. All right. If you have questions, please come back and see me. But the biggest key to this one is making sure your calculations are correct. So take your time when you're adding and subtracting and figuring those out. All right. If you have questions, please reach out. I look forward to helping you.